Lesson 8-4, Elimination using multiplication. And in this lesson, you learn to solve systems of equations by using the elimination method with multiplication and addition, and to determine the best method for solving systems of equations. Why is it important? Because you can use systems of equations to solve problems involving telecommunications and geography. And let's take a look at a real-world application on telecommunications. GBT MobileNet provides monthly plans for cellular phone customers. Carla Ramos and Robert Johnson both selected Plan B, for which monthly charges are based on per minute rates of calls during peak and non-peak hours. Okay, in 1 month, Carla made 75 minutes of peak calls and 30 minutes of non-peak calls. Okay, and her bill was $40.05. During the same period, Robert made 15 minutes of peak calls and 60 minutes of non-peak calls. Her bill was $35.10. Okay. What is the GBT MobileNet's charge per minute for peak and non-peak calls for Plan B? Okay, so in this case, we go back to our let statement, and in any word problem, we start with a let statement, and our let statement would be let P be the rate per minute for peak calls, and N represent the rate per minute for non-peak calls. Okay, then the information in this problem can be represented by the following systems of equations. Okay, so let's take a look at the two equations that we can derive from this problem. Okay, the first one would be 75p plus 30n equals $40.05. 75 being 75 minutes that Carla made during peak calls, and 30 minutes she made during non-peak calls, and her total bill for that particular period was $40.05. Okay, the next equation that we can derive from this is 50p plus 60n equals $35.10, where 50 minutes is where Robert made 50 minutes of non-peak calls, and 50 minutes of peak calls and 60 minutes of non-peak calls. Okay, and his bill for that period was $35.10. So these are the two equations, and it's asking here, okay, what is the GBT mobile charge per minute for peak and non-peak calls on Plan B? So basically, we want to find the value of P and the value of N given these two equations. So far, you have learned 4 methods for solving two linear equations. Okay, we have the graphing method, okay, the substitution method, addition, and the subtraction method. Before we solve this, let's take a look at this one. Okay, so what's the best time to use the graphing method? The best time to use the graphing method is this: if you want to estimate the solution. Okay, since graphing usually does not give an exact solution. So if you simply want to estimate the solution of your system of equations, the graphing method would probably be the best method. Okay, substitution. If one of the variables in either equation has a coefficient of 1 or -1. So again, remember the definition of a coefficient. A coefficient is the number before the variable. If the number before the variable is either a 1 or a -1, substitution method is the best method to use. The addition method. If one of the variables has opposite coefficients of the two equations, so if they're opposite, all you need to do is add them, you get rid of one of the variables. The subtraction method, if one of the variables has the same coefficient in the two equations. So if they have the same coefficient, okay, all you need to do is use the substitution method. Now if you look at this equation right here, okay, It seems that none of the four would be very applicable to this to these two equations, the substitution, addition, subtraction, and definitely not the graphing method. Okay, so the system above is not easily solved using any of these methods. However, there is an extension of the elimination method that can be used. Remember, addition and subtraction are elimination methods, elimination by addition or elimination by subtraction. Okay, so what we can do is multiply one of the equations with some number so that adding or subtracting eliminates one of the variables. Okay, so basically for this system, okay, we want to first multiply the first equation by -2, okay, and add, and the coefficient of n, okay, in both equations will be 60 or -60. Okay, so let's see how this works. So again, we look at the first equation, 75p plus 30n equals $40.05. 50p plus 60n is $35.10. And this is equation, we'll number them. Equation 1, and this is equation 2. Okay, so it says there, multiply the first equation by -2 and add. Then basically what happens, you multiply by -2 and you end up with -150p minus 60n equals -80.10. Okay, and we simply add. So by multiplying the first equation by -2, look at this. Now we can use the, since they have opposite coefficients and the same for the variable n, okay, we can simply add these two and eliminate the variable n. So if we do this, end up with -100 equals -45, and divide both sides by -100, p equals 45. Okay, so that is the value of p, and as soon as we find out one of the variables, we simply substitute that value of that variable to any one of those equations. Okay, so now we can solve for n by replacing p with 0.45. In this case, we will use equation 1 for this one. So we go back to equation 1 and we substitute, okay, the value of p 0.45. Okay, so this becomes now 75p plus 30n equals $40.05. That's equation 1. Substituting the value of p, which is 0.45. Okay, we end up with 33.75 plus 30n equals 40.05. Okay, subtract 33.75 to both sides, end up with 30n equals 6.3. And finally, divide both sides by 30, n equals 0.21. Okay, now, so the value of n, which represents non-p calls, is 21 cents, and the value of p, which represents p calls, is 45 cents. Okay, since the ordered pair of 0.45 and the ordered pairs 0.45 and 0.21, is this a solution? Okay, so to simply answer this, we go back and check our answer. Go back to equation 1, substitute 0.45 and 0.21 to p and n respectively. You end up with a true statement, and we go to equation number 2, 50p plus 60n equals 35.1, and we substitute p and n respectively, end up with a true statement as well. Okay, so the solution of this system is 0.45 and 0.21. Thus per minute rate for p calls is 45 cents, and the per minute rate for non-p calls is 21 cents on this plan. Okay, and let's move on. For some systems of equations, it is necessary to multiply each equation by a different number in order to solve the system by elimination. You can use to eliminate either variable. Okay, let's take a look at what this means in the next example. We want to use elimination to solve a system of equations in two different ways. Okay, you have 2x plus 3y equals 5. 5x plus 4y equals 16. Again, good practice to number those equations, equation 1 and equation 2. Okay, so method 1 is this. You can eliminate the variable x, okay, by multiplying the first equation by 5 and the second equation by 2, and then adding the resulting equations. Now, if you notice, if I do that, okay, 2x plus 3y, okay, and I multiply it by 5, okay, end up with 10x plus 15y equals 25, okay. If I have 5x plus 4y equals 16 and multiply it by negative 2, end up with negative 10x minus 8y equals negative 32. So what do you notice if you multiply equation 1 by 5 and equation 2, okay? So equation 1, if you multiply equation 1 by 5 and you multiply equation 2 by negative 2, you notice that it ends up, okay, you have the LCM of 2 and 5. So the least common multiple of 2 and 5 is 10, okay, and that's why you multiplied by 5 and negative 2. Now, why is negative 2 not simply 2? It's simply because if you multiply it by negative 2, you don't need to use a subtraction method to eliminate the value for the variable x. Okay, so basically you want to find the LCM of the coefficients. In this case, we found the LCM of 2 and 5, which is 10, and we simply multiplied negative, instead of 2, we multiplied by negative 2. Now, can I multiply by negative 5 and multiply by 2? By all means, yes. So you can do it the opposite way too. You can multiply the first equation by negative 5. You can multiply the second equation by simply 2, and you still achieve the same result. Okay, now if we use the addition method now, we have now 7y equals negative 7, and then we simply solve for y equals negative 1. Okay, and from there we simply substitute, okay, negative 1 to find the value of x, okay, using one of the original equations, and in this case we will use equation number 1. So if you use equation number 1, okay, and y equals negative 1, end up with 2x plus 3 times negative 1 equals 5, and 2x minus 3 equals 5. Solve for x, we add 3 to both sides, end up with 2x equals 8, and divide both sides by 2, you end up with x equals 4. Okay, so the solution of the system is 4 and negative 1. Okay, now if you want to check if our solution makes sense or not, we simply graph it. So if you graph one equation, we'll graph the second equation, and since both the x and y coordinates are whole numbers, you can see that they both intersect at 4 and negative 1. Okay, you probably guess what the method 2 is. Remember, in method 1 we found the LCM of the coefficients of x. Okay, in method 2 we will find the LCM of the coefficients of y, and then multiply one of them by negative 1. Okay, so in this case, if you already noticed, the LCM of 3 and 4 is 12. So what we do is that we can solve the system by eliminating the variable y, multiply the first equation by negative 4 and the second equation by 3, and then add. Okay, so when we do that, we have 2x plus 3 equals 5, multiply it by negative 4, end up with negative 8x, okay, minus 12y and minus 20, and you have 5x plus 4y equals 16, multiplied by 3, okay, to find the LCM of 12, end up with 15x plus 12y equals 48. Again, let's go back here, okay, Now, question is, can I multiply by negative 3 and multiply by 4? Yes, you can. Okay, so either method works. So you can either multiply this by negative 4 and 3 or multiply it by 4 and negative 3, and you still end up with the same solution. So solving that, you have 7x equals 28, okay, and x equals 4 after solving for x. And now we simply use x equals 4 and substitute it back to find y. So we get a 4 substituted to 2x, end up with 2 times 4 plus 3y equals 5. Okay, 8 plus 3y equals 5. Subtract 8 to both sides. 3y equals negative 3, and divide both sides by 3. Y equals negative 1. Okay, so the solution is 4, negative 1, which matches the result obtained with method 1. So you can see how the LCM works in the elimination method. Let's take a look at the next example. Example number 2. Okay, Luis Diaz discovered while entering the test scores into his computer that he had accidentally reversed the digits of a test and shorted a student 36 points. Mr. Diaz told one student that the sum of the digits was 14 and agreed to give the student his correct score plus extra credit if he could determine his actual score without looking at his test. What was his actual score on the test? This is a classic example of a digits problem. Okay, so when you see these types of problems, it's called a digits problem. And just like any word problem, we always started with a let statement. So let t represent the tens digit of the score, and let u represent the units digit, or the units digit also stands for the ones place. And the reason why we don't represent it with O is because the O will look like a 0. So let's just use U, okay, for the units digit. Okay, so the actual score on the test can be represented by 10t plus u, because normally you would multiply the tens place by t and multiply the ones place by 1. Okay, hope that makes sense. The amount entered in the computer can be represented by 10u plus t. Why is it 10u plus t? Because if you look at this one carefully, he said he accidentally reversed the digits of a test score. So basically what it's saying is this. Okay, let's say if the actual number is 34, okay, what he did was he reversed it to become 43. And that's the reason why you reverse the two digits, the units digit and the tens digit. So the amount entered in the computer can be represented by 10u plus t because the digits were reversed. Okay, so let's plan to solve this problem. First and foremost, okay, since the sum of the digits is 14, one equation is t plus u equals 14. Okay, it says there, the sum of the digits was 14. You simply get t plus u equals 14. Okay, since the teacher accidentally shorted the student by 36 points, you would get this equation, 10t plus u, which is the original number, minus the reverse number of 10u plus t equals 36, because he shorted the students by 36 points. And if you simplify that whole expression, you'll end up with 9t minus 9u equals 36. Now you have your two systems of equations, okay? And this is equation 1 right here. And this is equation 2 right here. Okay? So let's write it out. 10tu plus u equals 14. And the next equation is 9t minus 9u equals 36. You want to get rid of one of your variables right away. So in this case, the best way to do that is multiply both sides by positive 9, because if you notice, if I multiply both sides by positive 9, I can eliminate the variable u. So multiply by 9, end up with 9t plus 9u equals 126. Okay, and then you simply copy down the second equation and you simply add them, end up with 18t equals 162, and divide both sides by t equals 9. So the tens digit is 9. Okay, now let's find the other variable u by substituting t to one of the equations, and in this case t plus u equals 14 is the easiest equation to use, so we'll use that. Okay, t plus u equals 14, substitute the value for t for 9, 9 plus u equals 14, and simply solve for u, subtracting 9 to both sides, u equals 5. Okay, so the solution is 9, 5, which means that the student's actual test was 10 times 9 plus 5 equals 95 points. So basically, Mr. Diaz accidentally put 59 instead of 95. So the sum of the digits, 9 plus 5 equals 14, and if we check it, 95 minus 59, the difference is also 36. Okay, and that's a good example of a digits problem. Okay, before we continue with example 3, the secret word for this lesson would be showtime. Secret word for this lesson would be showtime. Okay, let's take a look at example number 3. Okay, in example number 2, we talked about a digits problem, word problem. In example number 3, we're going to talk about, okay, going back to distance, uniform motion problem. This is a current problem. Okay, so you can use systems of equations to solve problems involving distance formula. Rate times time equals distance, so we will use this formula, and we will. This is what we call a current problem, because it's going to talk about current of a river or a stream. So a riverboat on the Mississippi River travels 48 miles 48 miles upstream in 4 hours. Okay, the return trip takes the riverboat only 3 hours. Find the rate of the current. So we want to find the value of R of the current. So what do we know? Okay, and this is a good example of a current problem. Let R represent the rate the riverboat is still in still water. Okay, so let's see, represent the rate of the current. So the R will be the rate of the riverboat in still water, and C will be the rate of the current. And then that, if that's the case, then we can represent R plus C be the rate of the riverboat traveling downstream, okay, with the current. Okay, why? Because as you're traveling downstream and you're traveling with the current, you're basically adding the speed of the current to the speed of the riverboat. That's why you represent it with R plus C. Okay, and R minus C, because now as you are traveling upstream, so R minus C will represent the rate of the riverboat traveling upstream, because as you travel upstream through the current, okay, the current will go against, okay, your riverboat, and now you're subtracting the speed of the current to the speed of the riverboat. So R minus C will represent the rate of the riverboat when it's traveling upstream or against the current. So again, okay, current problem, R plus C will always be with the current, R minus C will be against the current. Okay, so how do we plan to solve this? Okay, use the formula again, rate times time equals distance, or rate RT equals D, to write the system of equations. Okay, then solve the system to find the value of C. And guess what we're using? Our favorite table. Okay, there's our table we use for uniform motion problems. But remember, last time we solved our uniform motion problem, we used only one variable. Now we can use two variables. Okay, so downstream, okay, let's fill it in this chart. Again, it's R plus C, and upstream will be R minus C. The time it takes to go downstream for the river boat is 3 hours. We know that. And for upstream, it took 4 hours. Of course, the distance never changes, so they're both 48. Okay, and if we follow the formula, okay, and use the formula RT equals D, and distribute 3 to R and 3 to C right here. So if you distribute that there and there and R4, because we're multiplying according to the formula, if we do that, we end up with 3R plus 3C equals 48. Okay, and 3R minus 4, sorry, 4R minus 4C equals 48. Now we have a system of equations. 3R plus 3C equals 48 and 4R minus 4C equals 48. Okay, and we want now to eliminate one of the variables. And if we multiply both the first equation, let's name our equations now. Equation number 1 and equation number 2, downstream and upstream. If we multiply equation 1 with 4 and equation 2 with 3, we would find the LCM of 3 and 4, which is 12. So we multiply that by 4, end up with 12R plus 12C equals 192, and multiply 4R minus 4C by negative 3 this time. Okay. We end up with negative 12R plus 12C equals negative 144. Actually, what I said in the first place would have worked. Okay, so if we simply multiply the first equation by 3 and the second equation by 4, we eliminate C right away. Sorry, the first equation by 4 and the second equation by 3, we can eliminate C right away, because this is how it's going to look like. If we multiply this one by 4, this will end up with 12R, okay, plus 12C equals 192. And if we multiply the second equation, okay, that will be 12R, forgot the R, minus 3C, sorry, 12C equals 144. So both methods will work. So if we do that, if we without the negative 3, we can already eliminate C. But in this case, okay, the book is trying to eliminate R first. So we'll follow what the book is saying. So this becomes now 12C or 24C equals 48 when you subtract the 2. Divide both sides by 24, C equals 2, and we simply substitute. Okay, well, we don't need to because we already found C. It's just asking for the rate of the current, and C, since C represents the rate of the rate of the current is 2 miles per hour. Okay, so find the value of R for the system and then check the solution. So if you want to find the rate of the river boat in still water, we simply have to substitute 2 to R, and we find the rate of the river boat in still water. Okay, and that's the end of our lesson. Thank you for watching.